Good day, teacher. My name is Musa Aminu Musa. My student ID number is 20090700012. This video was recorded on March 19th, 2026 by 11:31 p.m. I know I'm kind of late, but you'll give me some grace for that. In this presentation, we're gonna do the steps 4, 5A, 5B, 6A, and 6B. And we're gonna include the differences in the programs, the routing behavior, and key networking concepts. So let's get started. For step 4, which is about the fully automatic static routing table, in this step, basically, the network uses an automatic IP configuration from the configurator, but it also automatically creates routing tables for all the nodes in the network. The main goal here is that it allows communication between different hosts across different networks without manually defining the routes. The key difference here is that when routing is introduced, the other steps focus mainly on IP address assignment. But this step extends this by enabling end-to-end communication using routing tables, and that's actually very important. So in the code, we define an application using the ping pong app where host 1 sends packets to host 7. This allows us to test whether the routing tables are correctly formed. Then the routing tables are automatically generated by the configurator. Sorry. The routing tables are generated by the configurator on the network topology. Each entry in this routing table basically includes the destination address, the next hop, the interface used, and the metric value. The shortest path is determined automatically by the configurator, and typically we base this on the hop count or the default metrics we already have. The algorithm will now select the path with the least cost between source and destination. You know. The fastest path we use is not explicitly configured in this step, but you can basically consider it the same as the shortest path for this particular one because no custom metrics are defined yet. And then the simulation will just visualize the routing tables and allow us to see how the packets move from host 1 to host 7 across the network. This step demonstrates how the automatic routing table simplifies networking configuration and ensures connectivity between all nodes. You know. So basically we start here. This section basically defines the core configuration of step 4. The next part, we configure the ping app, and this sends one host from host 1 to host 7 and to test the connectivity. After that, this part here, it enables us to visualize the routing tables so that we can observe how the routes are formed and used. This part, basically, the configuration also dumps routing information, which helps us analyze how routes are generated. You know, it's pretty simple. Moving on to step 5. In this step, like I'm gonna explain there are two parts, 5A and 5B, but I'm gonna start with step 5. And what this does, it basically focuses on manually overriding the routes to a specific host. Instead of relying on the automatic routing like we did in step 4, we manually define a route for a particular destination. The main difference from step 4 is that here we take control over routing decisions by specifying exactly how packets should reach a certain host. In the XML configuration, the first thing we do is assign IP addresses automatically to all interfaces we use by using a general rule. Then we define the specific route inside the router 0. This route will tell the router that it wants to reach destination IP address 10.00.35. It should forward the packet to the gateway 10.00.18 using interface channel 1. But the next mask 255, 255, 255, 255, what this means, and it's very important, is that this route is for a single host, not a network. The metric value is set to 0, and what this means is that the route has the highest priority and it will definitely be preferred over the others. This step basically just demonstrates how the manual routing can override automatically generated routes and gives you more control in the network configuration. In terms of like the shortest path, this manual defined route, it will be chosen regardless of the automatically calculated path because we explicitly specified it. So this part especially, it is very useful in real networks when we want to enforce a specific path for performance, security, or policy reasons. You know. So basically, this part of it, the code, it says here for all interfaces, they're automatically assigned IP addresses. You know. The other part here is that on this line, I'm gonna break it down for you. The part where it says destination, that targets the host IP address. The part that says net mask means the route is for a single host. The gateway is where the next hop packets are forwarded. And the interface is which specifies which interface is used for the packet. The metric, we talked about that already, it defines the priority and the lowest values are preferred. You know, back into number 4, how this connects to it is that this step extends for, meaning it keeps automatic routing but overrides specific routes. Now, moving on to step 5b. This one is about manually overwriting routes for a set of hosts instead of a single host. That's the difference basically between 5a. It's similar, but the main difference is that 5a is one specific destination and this one is for the entire subnet. In this configuration again, we see IP addresses telling automatically to all interfaces, but the root of the definition is different. Here, the destination is 10.00.32 with a next mask of 255.255.255.248. This means that the route applies to a group of IP addresses within the subnet, not just one host. The router, which is router 0, will forward all the packets destined for the subnet to gateway 10.00.18 using interface channel 1. Compared to step 5a, where we use a net mask of 255.255.255.255 for a single host, this step uses a subnet mask to cover multiple hosts. And basically, this makes the routing way more efficient because one route entry can handle multiple destinations. In terms of the shortest path, this manually defined route will again override automatically generated routes. And that basically ensures that the traffic of this subnet follows the specified path. This approach actually is commonly used in the real networks to simplify routing tables and improve scalability. And yeah, so basically this part of it assigns IP addresses automatically. Yeah, and the other part it assigns it differently, you know. So the network mask is defines a subnet, meaning that multiple hosts are included on this route. Packets are forwarded to the next one, and for the interface, as you know, is the outgoing interface for the transmission. Now, linking back to step 4, the part of where it says configuring step 5b extends step 4, this step builds on step 4 but overrides routing like in step 5a. That's the key difference. Now, moving on to step 6a. In this step, the routing is still automatic, but instead of using the default shortest path based on hop count, we change the metric to data rate. The main difference though is that from the previous steps, the routing decisions are now based on link speed. The link speed is the difference here as we can see, meaning that the fastest path is selected instead of the shortest path. In this configuration again, we assign IP addresses to all interfaces automatically. Then we use auto route function with the metric rate set to data rate. This means that the configurator evaluates all possible paths and selects the one with the highest bandwidth links rather than the one with the fewest hops. The highest bandwidth links rather than the one with the fewest hops. That is a clear difference. So as a result, the path with more hops may be chosen if it provides a higher data rate and better performance. This demonstrates how routing can be optimized based on performance criteria, which is very important in real life networks where speed matters more than just distance. To summarize it all, step 6 just changes routing behavior from shortest path to fastest path using data rate as a metric. Yeah, the parts where it says XML interface, this part assigns IP addresses automatically, as we all know. But for this line number 3, where it says auto routes, I'm just gonna break it down for you to understand the line fully. That part basically enables the route generation. For the source host, this applies routing to all hosts. The metric, as we talked about, which is the most important part, is the data rate. This tells the system to use the link speed as the routing metric. The key concept here, honestly, from 6a is that the difference between the shortest path and the fastest path. The shortest path is based on the number of hops between nodes, while the fastest path is based on link performance, such as data rates. Now, the difference from step B is that step B uses manually routing for specific destinations, while step 6 returns to automatic routing but changes how the path is calculated. You know, the difference between step 4 is that the routing was automatic and based on default metrics like the hop count. In step 6a, routing is still automatic but uses data rates to determine the best path. Moving on to step 6b, which is our last step. Now I'll explain step DB, and this one focuses on manually specifying link cost in automatic routing. In this step, routing is still automatic, but instead of relying on the predefined metrics like data rates, we manually influence the routing decisions by assigning a cost to a specific link. Compared to step 6a, where routing was based on data rate to find the fastest rate, sorry, step 6b compared to step 6a returns using hop count as the metric, but the difference now is that it introduces manual cost control. In this configuration, the IP address are again assigned automatically. Then in the auto route section, we define the routing metric as hop count. However, we also specify a link with an infinite cost. This effectively tells the routing algorithm to avoid this link when calculating routes. So as a result, even if the link we use would normally be a part of the shortest route, it will not be selected because its cost is too high. What this does is that it allows us to control the routing behavior manually while still using automatic routing overall. Overall, this process or this approach rather is more useful in the real life networks because when certain links are unreliable or congested, or like we have to avoid them for policy reasons, we can use this. So in summary, step 6b combines automatic routing with manual cost adjustment to influence path selection. And yeah, as you can see, we have the coding, the everything. The parts of the auto route routing is based on hop count instead of shortest path being normally selected. Interfaces, we have the cost, which is the infinite, and that is very, very important actually, which is even the most important part because this assigns a very high cost and this disables the length for routing. The key concept here that we get from 6b is that we have manual control of routing cost. Mm. And yeah, that is about it. I hope I was able to be clear and concise to explain the key differences from each other, the differences between shortest and fastest routes, and the importance of each specific step for network optimization and what each one gives to the user. Thank you, teacher, and hope you have a good day.